Okay, so we're going to do a manual compression test on this car. Why would we do a manual compression test? Two reasons you're going to want to do it. Say we have a cylinder that's misfiring, and we know it's misfiring. We did a power balance test, and we had a misfire. We did a relative compression test, and we have a low cylinder. It's like, okay, what's going on with this thing? So we're going to do a manual compression test and just verify that there's something going on with this cylinder or some kind of a problem or anything like that. The other reason we might want to do a manual compression test, the customer might come in and say, hey, I want to know the condition of my car, and so I want to do a compression test to find out, is the car healthy or not. Don't do that very often, but on occasion it happens, and so we'll want to do it the whole car that way. So you can do, if you're just trying to do one cylinder, you're trying to figure out, the health of one cylinder, everything, surely you can do one cylinder and maybe do another good cylinder, compare it to it, and just to say, okay, we know we have some sort of a mechanical problem, we can just go after that. Remember, we're not trying to, you don't have to diagnose the whole, all the cylinders if we only know we have one cylinder going bad. We're just trying to chase it down to one cylinder. But we do want to make sure, if we're doing the health of the vehicle, we want to know that each cylinder, that the lowest cylinder is within 75% of the highest cylinder, okay? We don't want to see it any more than a 25% difference between cylinder to cylinder. I know that most of the literature that's out there is going to tell you to disable the fuel system and do this and do that, but we're not interested in getting too intrusive with the car. And the most easiest way to do it, especially on a Ford product, is we're gonna find the starter relay or the wire going to the starter, and we can simply crank the engine that way. We don't have to have the key on to do it, so we don't have to worry about the ignition going off. We don't have to worry about the fuel system going on or anything like that. We can just simply crank the engine. Now, one of the things we're going to have to do is try to figure out how to safely prop the throttle body open. Remember that the car is nothing more, the engine is nothing more than an air pump when it's not running. So we're just cranking it over, and if we have a throttle plate closed, now we've created a suction. So what we want to do is we're trying to find the perfect health of this engine. So we want to have the throttle body open so that we can have a full air flow through the engine to find out what the compression actually is. So the first thing we're going to do, we're going to go to the workshop manual. We're going to find out where the relay is for the starter. We're going to find the starter relay. So that we can jump it. We're going to find out how we can hold that throttle body open, and then we're going to do a compression test. Okay, so we've come to our PTS website. We're booted up on this car on the PTS website, and we're on our Oasis homepage, but we're going to come over here to the wiring diagram, okay, and we can go in here to the table of contents, and we can go to fuse and relay information, and we can find, if we come in here, we can see that our starter relay is right here. So we can go to the battery junction box, and we can jump the starter right there and not have to worry about any of the ignition system problems. We can come in here to the fuse box. We can just pop the cover on this fuse box, and we can know that this was the one that it was pointing at. And I have a cool tool over there we can pull this out with. Ready? Yeah. So we're just going to pull the relay out of here. Just going to put some terminals in on the relay here. And we have a cool starter button. All we have to do is clip onto these wires. And voila, we can crank the engine over. Okay, so the first thing we're going to do is we're going to pull all the spark plugs out of the vehicle. So we have to get the spark plugs out of this car, we have to pull all the coils out. Now remember that it's important that always important that we keep all the coils and the spark plugs all in their proper order, all where they came out, so that they go back in the same place. Okay. Remember that if we're trying to find out what's going on with this car, we start mixing parts up. You could move a problem around and be chasing your tail all day long. So always want to put them back in the same order. So we're going to lay them out on the bench over here. In the order in which we pulled them out. Okay. And I think we already had number 1 out because we were. Now, one thing I want to mention as you're pulling spark plugs out of a vehicle is it's important that you use a spark plug socket. You can't just use a socket that fits the spark plug. It has to be a spark plug socket. And the reason for that is, and you probably can't see it, but inside here there's a rubber boot inside there. And what that does is it causes the spark plug to stay square in there. If it's not in there, you can get cocked on these in the socket, and it will every single time. Every single time it will break the spark plugs, okay? And so we don't want to have broken spark plugs. And that rubber boot is really designed to hold that spark plug as well as when we pull it out of here. And it is not holding on this particular one because it is an old, worn out spark plug socket, but and these are nice and hot. Ooh, they're hot. Okay, this is a good time to pause, and as we pull all the spark plugs out, we're looking for the health of this engine. And so this is a good time to pause and look at the spark plugs. Now, these aren't the plugs that came out of this car, but I just have a few spark plugs here that have some problems to be able to say, okay, what are we looking at in this car? So if you'll zoom in here on these spark plugs, we can see this one here, obviously, it was pretty obvious when we pulled this out of the vehicle, something went through that cylinder and ate it up. Okay, likewise with this one here, you can see the gap is closed up. Something went through that cylinder and bent that up. Okay, you would see that this one here is really, really white, but also the other thing we see on this one here is it was full of water and really rusty. Okay, so we were looking for a misfire. It's like, oh, hey, look what we found. Okay, we have one here that looks really good, really normal. That's what I'd expect to see. And then we can have one here that's all, can you see that? All black and fouled. That's usually going to be an indication. I think we pulled this one out of a car that was eating coolant and fouled that spark plug. So then I have another one here that, if you can see, can you see that black mark on there? Okay, that's called carbon tracking. Really common to find them on spark plugs, but it's really common to find them on these. This is out of a 3.5 EcoBoost turbocharged engine, and I'm not sure if you can see it inside of here. I don't know, can you see inside there with that camera? Probably not, but you can see the mark, and what that does is the spark instead of going through the spark plug, it goes down the side, and that's what causes that carbon tracking, and it causes a misfire. Okay, so now we're back to the compression test. So we're always going to want to find a compression tester adapter that's going to match the spark plug thread size, and it's important that we don't get a spark plug adapter or compression tester adapter that's longer than the spark plugs. Remember, if it was longer, what could it do? It could actually go in and hit the top of the piston, and that would be a problem. So all we're going to do is thread that into the hole. Okay, so we've hooked our compression tester up there. Now, one of the things there's two things that we're looking for here. First is, how was the first hit? Was it good and strong? Was it weak? Or and then what was the final compression? So we're gonna watch the first hit, record the first hit, and then we're gonna crank it 4 or 5 times. So can you see that good on the screen there? We go 1, 2, 3, 4, 5. Okay, so the first hit was somewhere around 70 psi. Would everybody agree with that? And then we ended up with about 160 psi. We're on cylinder 2 here, and we'll get our first hit. Okay, that first hit came in at about 75. So let's see what 1, 2, 3, 4, 5. So we're at roughly 160 to 170 psi right in there. Okay. And again with cylinder 3, our first hit 75 psi, and then okay, we're roughly 170, 175, somewhere in there. Okay, and we're now on cylinder 4. Okay, that first hit was about 75 again, and okay, and 170 pounds compression. Okay, so our compression readings there are well within specification. We don't really have any kind of problem. Now, when we say specification, most manufacturers do not give you a specification as to what the compression should be on an engine. They might give you a minimum. Ford does not give you any of that information on any of their vehicles. They might on some of their diesels, but on their gas engines, they do not. All they do is make sure that you are within 25% of each other, okay? Now, we're going to go ahead and do a wet compression test on here, and if we had a cylinder that was maybe a little bit low, maybe 25% low, we want to find out, is my problem in a valve or is it a piston ring or something like that? We're going to do a wet compression test. I don't have a bad vehicle here to show you, but we're going to go ahead and do a wet compression test on here, show you how to do it, and then we'll talk about how to interpret those numbers so that you can, another useful thing in your toolbox, find out what's going on with this car. Wet compression test, you asked, okay? Remember in our lubrication class, one of the things that the lubricating oil does for the engine is it seals the cylinder walls. Remember the jaggedness of the cylinder walls, and those piston rings come down. If we don't have oil there, we don't have a good sealing. So oil on the cylinder walls helps that seal. So if we have weak rings or something like that, we're not getting a good seal there. It's a possibility that's where our compression is going. So we're going to add oil to the cylinder and take a compression test again to find out if it's going to help the sealing of that engine. If it does, we know that we have a ring problem. If it doesn't improve the compression, then we know we've got a valve or a head gasket issue. So all we're simply going to do is take an oil can, and it's just going to squirt about a tablespoon of oil on top of the piston. I've got a hose on here so we can kind of get down inside the cylinder and not just squirt it in the head. And all we're going to do is add a tablespoon of oil to each of the cylinders one at a time, and just redo a compression test and take those numbers down, and then we're going to evaluate that engine after we take that test. All I've done is stick this vacuum tube into the spark plug hole. We're going to give it a few shots of oil. Okay. And we're going to redo the compression test. Screw that in there. Okay, we're going to do the same again. We're going to watch the first hit. 75 pounds. Okay, and that bumped us up to a solid 175 on cylinder 1. Okay, we're going to get some oil in that cylinder too. Just going to set this off to the side. And 1, 2, 3. Look at that cylinder. 210 psi. Mm-hmm. Really made an increase in that cylinder. Oiled up this cylinder. And 200 psi. Okay, oiled that cylinder. And okay, about 185 psi. All right, so what do we interpret from this? All of a sudden, we've got one that's pretty much stayed the same, and then one that went way up. I think what we can learn from this is that what I did purposely was I put only a little bit of oil in one, and then I over-oiled another. It's important that you put the same amount of oil in each cylinder, because obviously having that oil in there is really going to affect that cylinder and cause it to increase its compression. If it's just got, if the rings are okay, if the valves are okay, it's just going to increase the compression because it's sealing that piston up so well. So the point of this whole thing is that if you're going to, when you do a wet compression test, you should see an increase in compression in the cylinder. And if you don't see an increase in compression in the cylinder, you know that there's something going on with a valve or a head gasket or something like that. It's just another tool in our box that we're trying to say, get it right down to what exactly is going on with this car. Why is this cylinder got low compression? And so now we're going to do one more test and show you if we've got a compression issue on one. We're going to try to find out where's that compression going. So we got one other tool we're going to try to show you. Okay, so this is your NATEV task sheet that's attached to your canvas, and we're just going to record these numbers. That was cylinder one was 175 pounds. And one more tool in our toolbox that I want to show you is to try to find out what's going on with this car. If we have an engine that's got a low compression in a hole, we want to know where it's going and how bad it's leaking. We have the cylinder leakage tester, and what it's going to do is going to give us a percentage of leakage that's going on in here. And we can find out whether it's going past the rings, or the intake valve, or the exhaust valve, or maybe through a cylinder head gasket to the cylinder next to it. So it can go one of four places: another cylinder, intake, exhaust, or out the crankcase and in the oil system. Okay. So what we're going to do is we're going to take this tool. We're going to hook it up to top air. We're going to adjust this to a set point, and you can see the set point at 0 right there. And then we're going to take it onto the cylinder, and we're going to show you what we're going to do next. Okay, so we're going to drop this in the spark plug hole, and we're going to thread it in here. Now, it's important that this cylinder be on, and this is where it can be kind of tricky. We're going to try to find top dead center on its compression stroke. In other words, we want to have the valves, both valves closed, so that we can put air in the cylinder and find out if it has a leak. Okay, so what we're going to do is we're going to crank this engine around until we got compression coming out that spark plug hole, so that we know. Okay, so we know that both the valves are closed and the piston's up. Okay, we've got this set to 0, and we're going to set that on there. Okay, and that's realistic of what you're going to see. You're going to have, you're going to get a little bit past the rings and stuff. That's a really well sealed cylinder in cylinder 1. Okay, and now if we had a problem, and I'm going to tap this engine around we're going to open a valve, we should be able to see. Okay, now we have a valve that's hung open. Now you can see that there's a leakage in the cylinder. What we're seeing is whether it's going to be, a low leakage, moderate leakage, or high leakage. And all this thing is telling us that we've got leakage coming out that cylinder. So it's another tool in our toolbox where what we're going to be able to do with that then is if we've got leakage out that cylinder. Now keep in mind that this tool is not pushing, gigantic amounts of shop air through that cylinder. So you have to go back to the exhaust or the intake or maybe the oil or maybe the spark plug or the cylinder next to it and listen real close and find out where's that air leaking through. Is it coming through an intake valve? Is it coming through exhaust? What we're trying to do is with all these tools is we have a power balance test that says, hey, we have a problem in cylinder 2. We do a relative compression test. It's like, hey, we have a problem in cylinder 2 with compression. We do a manual compression test. It's like, yes, we have low compression in that cylinder. So now we come here to one more tool, come in here to try to find, hey, we have a problem with an intake valve. Okay, so now you can go to Joe customer and say, hey, sir, we have a problem with your intake valve in cylinder 2. We need to spend X amount of money to pull it apart and find out what's going on. You can come to that customer with a certain level of confidence that says, hey, this is what's happening with your car, and this is what we need to do to try to fix it, or at least to go in and try to diagnose it, so that we're not just throwing parts at something or stabbing at something. So now we've taken we know what the symptom is, that we had a misfire. We've come down to a system. We've verified that the ignition system's working well, the fuel system's working well, and we know it's something going on inside that engine with the compression. And then we can go to find out what's the cause of the problem with a certain level of confidence, and then we can find out what it's going to take to correct the problem. And it might be a whole engine. It might be just simply simply a broken valve spring or something simple like that. So just another tool in the toolbox to be able to help us be able to figure that out. So.